So the first page, I'll ask you two like problem number one, not all four. I will maybe ask you a problem like number 2 or number 3, but probably not both. I don't think I'll ask you, if you flip the next page. So between 2, 3, and 4, I'll ask you a problem like one of those. 5, I probably won't ask you that one, so you can cross 5 out if you want. Yeah, and then 7, I mean, 2, 3, so yeah, 4, I might ask you a problem like 4 or like 7, one of those, probably, right, but not both. The next page, 10, there's a good chance I'm going to ask you one of those. 11, I might ask you one of those. 13, I might ask you one of those. Yeah, anyone, I'll probably ask you 1 or 2 of problems like that.
All those. 10, 11, 12, 13.
Yeah, I mean, you know, there'll probably be 1 or 2 of them like that, but you know, any of those there will be one like that. The next page, which says 1 or 14, it's really 14. I will ask you two problems like that. Not 4, but I'll ask you a couple problems like that. Next page, 15. The graph things, determine the domain and range from a graph. I'll ask you one problem like that. Not all 3 of them. So I mean, yes, this won't be. The problem is there's some variety in what I'm going to ask you. So depending on what version of the test you get, you might get one or the other. You know, so that's why I'm giving you kind of more. And then 16 and 18, definitely I'm going to ask you questions like that. Not 17. And then we have these solve for x's. Right? There'll be a bunch. There'll be like 6 to 8 of these. So there's 10 of them here. You should know all of those because I'll ask you, you know, probably 8 problems like that. I'm not sure which 8, but you should kind of understand how to solve all of those. Yeah, 11, definitely. 12, definitely. And then we get to, oh gosh, there's 213. Right, so you're going to have a direct variation and an indirect variation. So the next 4 problems, 13, 12, 13, 14, you'll have 2 problems like that. Not all 4 problems, but you'll have an indirect variation and an inverse variation. So of those 4, you'll have 2 that are like that. And then on the back, you'll have 15 and 16, you'll have a problem like one of those. Either it'll be a exponential growth or an exponential decrease. It'll be one of those. So yeah, so it won't be as long as this, but depending on what version you have, you'll have one of any, it's problems like this. You'll have, I just gave you extra ones to work on. Okay. So let's solve this problem here. Let's see, triple. So that's 4,500 equals 1,500 times 1.0325 to the t. And so you divide both sides by 3, and you end up with 3, or by 1,500, sorry, my bad. Divide both sides by 1,500. And you ended up with 3 equals 1.0325 to the t. So then take the log of both sides. So you end up with log of 3 equals t times the log of 1.0325. And you know that is, what do you get for log of 3?
0.477.
477 equals t. And we already have that log. You have from above. 0.01389. So then you divide both sides by 0.01389, and you end up with t equals, anybody? 45, was it 45?
34.
34? Point,
07.
34.
oh, 0.07?
Well, I think I rounded it.
I
a little
got
bit.
34.12.
Okay, so 34.1 years.
Yeah.
So what does that mean? Interpret that. I want to write down what that means in words. Yeah.
So I got a different decimal part than they did. So on the test, for
Did you,
the answer, so I got 34.565.
I got 34.
did you use this number?
Yeah.
And what did you round this one to?
I stopped at 8.
Oh, it should be 9.
Yeah.
So if you run it incorrectly, you'll be marked half point off
Okay.
for running it incorrectly. So you could have used 0.0139, that's fine. But you definitely should not round incorrectly and count that an 8.
But you can use 0.14, right?
No, you have to give me at least 3 sig figs. 3 sig figs.
So that's it.
First one, 1, 2, go to your first non-zero. Remember this is from chapter 1?
First non-zero.
First non-zero, 1,
Okay.
2, 3. Not 3 decimals,
Okay.
3 sig figs.
Okay.
If you round to 1, 4, it's no good. 3 sig figs.
Okay.
1, 2, 3. So like I said, you could definitely use 0.0139, that would be fine. Yeah. Okay, so what does this mean? Ryan, what'd you write down?
I said it'll take 34 years to triple.
Mm-hmm. Nice. To triple your money. Okay, good. All right, so that is it for that packet. I do want to take a look at our practice. And while we're sort of, yeah, okay, so maybe we should take a look at some of these, because it's been a little while. Right, what do you think? I'm game for looking, okay, so we have several options. We can go over more logs, or maybe we should wait till tomorrow, to next class, and go over more logs, so people have had a chance to forget them and then re-remember them. Maybe it's better, okay. We kind of refresh ourselves on exponentials a little bit right now. Do people want to do another exponential, or are you feeling kind of sort of okay with that? Or we can start in and kind of review some of the rates and ratios and place straightforward. Is this a rate or a ratio? This is the practice exam I just gave you folks. City guy.
Ratio.
I get one vote for rate, and what's the difference? So, why do you say it's a ratio?
Comparing dollars to dollars?
Because they're dollars to dollars, they have the same units. When they're the same unit, it's a ratio, it's a ratio, and they cancel out. The rates are things like what's a rate that you're used to?
Miles per hour.
Miles per hour. Or your pay rate, dollars per hour, right? Or have you heard our hotel rates, dollars per night, right? So rates are things that are different units. So when they're not different units, that's just a ratio. So here, this is a ratio. Because they're both dollars. So it's 272 to 144. And the dollars cancel out, so those just go away. Right? Dollars to dollars, those go away. And then you got to reduce it. So then I got to bust up my calculator and say, okay, well I know they're both even. So they're both divisible by 2. Are they both divisible by 4? 272 divided by 4. Yep. 144 divided by 4. Yep. Oh, and when I did do that, I get 68 over 36. Are those both divisible by 4? 68 divided by 4. 17, ooh, that's divisible by 4. So 36, is that divisible by 4? Yep, I get 9. And then I know that they're both not even, so they're both not divisible by 2. 9 is only 3 and 3. Is 17 divisible by 3?
No.
No. Okay, so I'm done. Does that sort of make sense? That's kind of how I do it. Just kind of work your way down. Okay, how about B? Is B a ratio or a rate? It's a rate, yep, because they're different. So 475 miles on 25 gallons. And you cannot remove the units do not cancel out. You gotta leave them in there. All right, so
But you can reduce.
25, right away I know they're both divisible by 5, right? Everyone with me? So I'm gonna do 475 divided by 5. What do I get? Ooh, I get a 5, so it's divisible. I can divide by 5 twice. So I know they're both divisible by 25. Does
Yeah.
everybody kind of follow me? So I'm gonna divide them both by 25. So I'm gonna do divide by 25, divide by 25, and I will get 95 divided by 5. 19 over 1. So I can go 19 miles, ooh, that's not very good, on 1 gallon of gas. That's an old car, man. Old car. All right, next one. Little Mikey can run 4/3 in the same amount of time, 4/3 miles in the same time his dad can run 3 and 1/3 miles. Am I gonna ask you a question like that? I don't know if I'll ask you one that hard. So, let's take a look at this. So first let's make them both into thirds. So I have 4/3. What's 3 and 1/3 really? I have 3 pizzas and 1/3 of a pizza. I don't have this part here, just 1/3. How many thirds are on a pizza? 3?
10.
Yep, so if I count them up, I have 3/3 here, 3/3 here, 3/3 here. So that's 3 times 3, 9/3 plus 1 more third, I have 10/3.
You just do 3 times 3 plus 1, right?
Yep.
To convert.
Why do you do 3 times 3? Because each of these has 3/3. So 3 of them times 3/3, that's why that 3 times 3 comes, plus 1. That's the 10/3. So here I'm going to have 4/3 over 10/3, and they're both miles. So since they're both thirds, I can make that into 4 over 10. Does everybody understand why I did that? 4/3 compared to 10/3, they're both thirds. Same thing as 4 over 10. Can I reduce 4 over 10?
Yeah.
By 2.
Divide by 2, and I get 2 over 5, yep. That's my final answer. Is this a ratio or a rate? Ratio, because they're both miles, so that I don't have any units. All right, good. How about the last one? Everyone do that one. I'm gonna take a minute, do that one on your own. The last one is more common. I probably won't give you something like C. I probably won't give you fractions in there. I'll probably stick with the whole numbers, like A, B, and D. So everybody do D? First of all, is it a ratio or a rate?
Rate.
Rate. Okay, someone's writing in there. Rate. And then did everybody get it? See that?
$50 for a week.
What, how much is it?
$350 for 1 week. That's honestly not that bad.
No.
Yeah.
For a condo?
Yeah, it's not bad at all.
That's great.
But it might be in the middle of nowhere that no one wants to be at.
$50 a day.
Don't know the
$50 a
location.
night.
Yeah. Okay, good. All right, so, unit rates, remember, unit rates are just where your denominator is one no matter what. So we just take it and we just divide. So, for example, $368.32, the unit rate, we can have decimals, because it's amount per whatever. So everybody find that. What did you folks find? How much you make per hour? Yeah. $11.50 an hour. So below that, it's just unit rates, unit rates, finding the unit rates for A, finding the unit rate for B, and then figure out which one is a better price. Remember, it's always money per can. The unit price means how much per item, the cost per item, so money goes on top.
What about B?
What about what?
B.
Yep, you can do that on your own. I'll let you folks do some. I'm not gonna do all of them. I just realized I shouldn't do all of them because you should do some of them, over the weekend to practice. So I'll leave you folks with those two to practice. I'll do 5 because we'll do 5 together. That's kind of the harder one, maybe.
So you had to
We'll
cross
cross
out
out
one.
that.
Okay, cross out 5. We'll do 4. We'll do 4. You can do 7 on your own. So Jamie gets paid $800 for a 30-hour work week. How many hours will she have to work to earn an extra $2,500 for the car? Does this say inverse or direct on it anywhere? Someone see that?
No.
No? Does anybody see exponential or linear? No? So if I don't give you any of those, then this is a regular, ordinary proportion problem. Is everyone kind of following what I'm saying? If it's direct, it'll say direct. If it's inverse, it'll say inverse. If it's exponential, it'll say exponential. This is none of those. So this is just a regular, ordinary proportion problem. So instead of a proportion, what are the two things that vary? What are the two things that vary?
Money and time.
Yeah, money and time. So money and time, or hours, I guess we'll call it. So I suggest you make the thing you're trying to find your x. So what are you trying to find?
Hours.
How many hours? Does everyone see the how many hours?
Mhm.
Is everyone on board with that? So I would make hours my x. Make that your x. All right, so I'm going to have x goes with $2,500. So everybody see how those two go together? What other two numbers go together?
830.
$800.30 hours. Someone see that part? So I'm going to put my x on top, x hours. So that means hours is on top. What's on the bottom?
Money.
Money. Yep. So how much money goes with x hours?
2,500.
Great. And that should equal, the other one, again, should have hours on top, money on the bottom. So put your hours on top, put your money on the bottom. Everybody do that. Now, it's a one-step thing to solve it, right? How do I get x hours by itself, x by itself? And now that I have them all in there set up right, I can even ignore the dollar signs and the hours, the labels. I can just do x equals. How would I solve this? Multiply both sides by what?
2,500.
2,500. So that's it. X equals. Everybody find it. Find it. Find it. Find it. not a whole number.
Is it 25/1?
Yeah, 2,500 over 1, you could do it like that, sure.
No, you just do it across.
Mhm.
30 times.
Yeah, you can totally do that. I got 93.75.
Mm-hmm.
Did anybody else get that?
I got that.
Yeah.
And 93.75 watts hours. Good. So I feel like number 7, I feel like you folks could sort that out too. Right, we're trying to find is the length of wall. So the length of wall would be your x. If you number 7, if you're unclear, 1 inch corresponds to 4 feet on a wall. Is that what I'm understanding? This should be 4 feet is on the wall. That's the length on the wall.
That's a scale.
Length of wall.
Yeah.
Yeah. So that's the same thing as feet and length of wall, the same thing. Ooh, these we haven't seen in a little while. These might be worth doing. Simplify. I cannot solve these. Do you see where it says solve? It doesn't say solve. There's no equal sign. You can't solve for x. All you can do is clean it up. So yours says y here, right?
Yeah.
So here, I can factor out some things. What can I factor out of 4y minus 16?
4?
4. And I'm left with y minus 4. Yeah? Yes?
Mm-hmm.
What can we factor out of the bottom?
6.
6. Everybody do that. Find what you're left with if you factor 6 out. Shania, what are you left with?
I'm not sure.
Okay. Number 10. Factoring 6 out of that.
It would just be 1y minus 4.
Okay, good. Is there anything that these folks have in common that I can cancel out? Ryan, what can I cancel out?
Y minus 4.
Y minus 4 over y minus 4, that goes away. So I'm left with 4 over 6. Am I done?
No.
Reduce.
No, I'm not done. Eric, what'd you say?
Reduce.
Reduce to what?
Reduce to 2/3.
Yep. Divide both sides, top and bottom by 2, I get 2/3. Good. All right, so the bottom one. How about the bottom one? 3x plus 1 times x minus 5, 3x minus 1 times 5 minus x. Can I cancel out the 3x plus 1 and the 3x minus 1?
No.
No, you can't, because that plus and that minus locks them in. Can I cancel out just the 3x and the 3x?
No.
No, because again, it's that plus 1 and minus 1 that kind of locks you in. That's a whole piece. But this, I should always have my x in front. I don't know why my x is not in the front. So I'm going to rewrite this. Negative x plus 5. Right, because the x should be in front. Okay.
Oh, negative x plus.
But my x is negative. So I can factor out a negative out of this. Does everyone understand what I'm saying? If I factor out a negative, what would I get? Negative 1 times what?
X minus 5.
X minus 5. So see that? So really this is the same thing as 3x plus 1 times x minus 5 divided by negative negative x minus 5. So you're going to place that one, and then I'll leave that 3x minus 1 there. 3x minus 1. Now, is there something I can cancel out?
Yes.
What can I cancel out?
X minus 5.
X minus 5. So now I have, I'll put the negative in front. 3x plus 1 over 3x minus 1. There's a negative in front. You can leave the negative on the bottom or the front. Usually people put it in the front. That's easiest. Resist the temptation to cancel out this 3x. You cannot do that. That plus and that minus, they freeze it.
What happened to the negative?
It's in front.
Oh, okay.
I'll make it a different color, maybe, or I'll make it closer. Maybe that'll be easier.
This didn't exactly follow how you, when you factored out the negative over here, the second step, I guess.
Over here?
Yeah.
It's right here.
I know, but what did you do to do
So
that?
then I just, I factor out the negative. I factor out a negative. So if I take a negative out of negative x, I get x. So I take a negative out of 5, I get negative 5.
Oh, you take a negative out of 5, you get negative 5? How do you take a negative out of 5?
What's 5 divided by negative 1?
I guess it's negative 5.
Yeah.
Oh, you're dividing? Oh,
Or multiplying.
okay.
If I were to factor it back in, if I were to do it back in, I'd get negative x plus 5, right?
Or if you spoiled it?
If I distributed it back in,
Okay.
right? So here are some other ones. I'll let you folks maybe work on those ones. This one you'll have to factor. Remember, people remember how to factor?
Yeah, you do the x.
Yeah. So maybe we move on. We'll come back to a couple of those later on today. Or you know what? We'll do a couple. Let me slide all the way down to okay. We'll do a couple of these. Find the domain of each rational function. So here, what's up with a rational function? You can never, ever, ever what? Divide by 0. So that means that this cannot equal 0. Right? So x plus 3 cannot equal 0. How do I solve for x, kind of, in a way? What would I do? Natalia, what do you guys should do? Minus. Yeah, subtract 3 from both sides. So I'll end up with x cannot be negative 3. That's my domain. X can't be negative 3. X is negative 3. All of a sudden, the world blows up, right? Right? And remember my shirt? Cannot divide by 0. So that's part for that. Yes. And then, so then my asymptote, or my whole, would be at x equals negative 3, because those go together, right? This is what x can't be. If x can't be negative 3, then x equals negative 3 is where my asymptote or whole is.
What's a hole?
A hole is
it the same thing as asymptote?
no, I'll show you what a hole is. A hole is
It's like a circle. I mean,
it's like a circle. It's this is a hole,
oh, there's a spot that it can't hit.
right? So that's a hole. Asymptotes would be here. Everybody
Yeah.
kind of follow on that part. So what's my domain of this one? X can be everything except for what? X can't be
Negative 1?
what?
Negative 1.
Negative 1. That's where my hole is. What else can x not be? Positive 1. That's where my asymptote is. What's my range? What can y not be? Someone else, someone different. can y not be? Look at the asymptotes, what can y not be? Anyone? Gabe?
Zero?
Y cannot be 0.
Yep. Y cannot be 0. So remember, whenever you have these asymptotes going on, that's what x or y cannot be. And it looks like it can be everything else, right? It kind of goes kind of through everything else. So that means that my vertical asymptote, my vertical is up and down, is at this spot right here. That's when x is what? Something's 1. Does everyone agree with me that something's 1 here? Yeah? So what's 1? Is that my x or my y that's 1? And you can look back and hear it and it'll tell you, right? My y equals 0, so that's not it, it's x equals 1. These go together. Which means that my horizontal asymptote must be y equals 0. Right, the asymptote is what y cannot equal. How do I know which one's the horizontal? Because that's the horizon, it looks like the horizon. And all you gotta do is pick 2 points along there and say, okay, or even pick 1 point, as long as it's not this, as long as it's not 0, 0, and say, oh, this point is 2, 0. So something's 0 along here. What's 0? My x or my y? 2, 0. Oh, that's my y. Y equals 0. So that'd be the easiest way of finding it. Here, something's 1 along here. What's my point here? 1, 0. Which one's 1? My x or my y? 0. So 1, 0. It means my x is 1. So this must be x equals 1. And that's a whole.
Yeah. So like back to 14A though, how would, based on the information I have here on 14A, how would I differentiate between asymptote and whole?
Oh,
That's what I'm kind of asking.
how do you know if it's an asymptote or whole?
Yes,
Um,
because that's what you're
Oh, on
asking. right?
14?
14.
I'm not asking to say whether it's an asymptote or whole. I'm telling you, just say what
Oh.
x can't be.
Oh, okay.
So I don't care whether it's an asymptote or a whole. You don't have to tell me what it is. You just have to say, I know that there's something going on. X can't be -3. I don't know if it's an asymptote or a whole, but it can't be that.
Okay.
So it happens at x equals 3.
Okay.
Yeah. That's why I said or whole, because it might be a whole.
Right, okay.
Yeah.
I thought you were asking us to
No,
circle one,
you
like,
have to say
which one is
which
it?
No. And then this one is kind of interesting because, remember here, x can be anything as I go along here. All right, can someone kind of see that? Actually, I don't want to do, well, so I don't want to do that one yet. I forgot. What I really want to talk about before we head out for the day is this one right here. 12. It's on the. It's 8th page. It's kind of far over. Is this one here? So if I simplify this one, I'm going to simplify. I have x squared minus x minus 2. So I need to have two things that multiply to -2 and add to -1. So what are two numbers that multiply to -2 and add to -1? 2 and 1. Which one's negative? The -2. Does everyone remember why? Because it has to add to -2, so the negative one has to be larger. So this is going to become, this part becomes x minus 2 times x minus 1. And then the bottom is two numbers that multiply to 12. You folks remember that one? Right? Here's my 12. Multiply to 12 and add to -7. So what are two numbers that multiply to 12 and add to -7? They have to be the same sign because they had to multiply it to positive 12.
-4, -3.
Yeah, -4 and -3. Perfect. So this one becomes x minus 3 times x minus 4. So my whole bottom becomes this. Yeah, times x plus 1. And then this one has an x minus 3 on top. And then now you can kind of see what cancels out. So what cancels out?
The above one, isn't it supposed to be x plus 1?
Oh, it is plus 1. I'm sorry. Plus 1. That makes more sense. Okay. Yeah, that's a plus 1. So now I have the x minus 3's cancel out, and the x plus 4's cancel out. Everybody with me on that part? Yes, no?
Yeah.
So then we're left with x minus 2 over x minus 4. Done. Good. All right, we'll see you folks on Friday. Are there questions about this at all before you head off? No? Yeah.
Nothing on here, so.